In previous CarbonGraph tutorials, we've explored how you can use parameters and expressions to enhance your model and build scenario analyses. In this video, we'll take it a step further with logic statements. Logic statements allow us to evaluate the environmental impact of several different options from a list, or encode model behaviors that are situationally dependent. We'll be using the same toothbrush model that you've seen in our previous videos. If you haven't watched them yet, check out the link above and learn how to get started with CarbonGraph. So in this toothbrush model, let's say we want to evaluate the environmental impact of two different handle materials, propylene and acrylonitrile butadiene styrene, or ABS. We'll add these two materials into our model, as I've done here, and I've connected them to what we call a material selector card. This material selector card is then connected to the downstream handle fabrication step. So why have I done this? Let's dive into logic statements. What I'm going to do first is create a parameter that determines which of the two materials we are selecting from when we calculate our environmental impact. So let's create a parameter called material switch. As I fill out the description of this parameter, let's define how we want this logic to work. Here, we want to define essentially two different states of our model. In one state, the model calculates with propylene as the selected material, and in the second, it calculates using ABS. This parameter is what will determine which state the model is in. Since parameters can only be numbers, let's say that if this parameter is equal to 1, then the model will calculate with propylene as its selected material. And if the parameter is equal to 2, it will calculate with ABS as its material of choice. We'll set the baseline value to be 1, or propylene for now. We'll call this unit a selector, and we'll set our limits to 1 and 2 so that we can never go lower or higher than those two numbers. Now here, we've only defined these two states, but we've yet to encode them in the model. This is where logic statements come in. So let's close out our parameter window and open up the expression box for one of these two materials. This is where we're going to start using if statements. If statements follow a particular syntax, which you can find in the syntax tips we have here below the input box. What we do is we start by typing an equal sign, just like we're typing in any other expression in CarbonGraph. We then type in if, and we open a parenthesis. Then we need to input three terms or arguments: the condition, what the expression should return if that condition is true, and what the expression should return if the condition is false. The first argument that we enter is that condition statement. Your condition statement compares two values, either parameters or numbers, and the if statement checks whether the condition you've defined is true or false. Your conditions can check whether two values are equal, whether one value is greater or less than another, or whether they are not equal to each other. So what is the condition that this statement is evaluating? The condition we want to evaluate is, does the material switch equal to 1? The second argument we enter is what the expression should return if the condition is met, if the material switch does equal 1. So in this case, if the material switch is equal to 1, then we want to return 1 kilogram of propylene. Finally, the third argument we want to enter is what the if statement should return if the condition is false. In this case, that would be 0. Then we close our parentheses. So what this expression is saying is if the material switch is set to propylene, return 1 kilogram of propylene here. And if it's not set to propylene, then return 0. So we've defined the condition, what to return if the condition is true, and what to return if the condition is false. If you can't remember the syntax, that's okay. There's two places you can find it. First of all, it's right here at the bottom of the expression pop-out window for reference. You can also find it by typing an equal sign into an expression input window, scrolling your mouse over to hover for built-in functions, and then seeing all of our operators, built-in functions, and built-in constants here. If there's other functions that you'd like to see added to CarbonGraph, please let us know and we can add them in. Going back to our expressions, what we've done so far is we've set up this first expression to say that if the material switch is equal to 1, then we're going to return 1 kilogram of propylene, and if it's not equal to 1, then we're going to return 0. And what we need to do now is set up the opposite case for our ABS input. So I'm going to open our expression input window and start typing out my if statement again. So in this case, our condition is if material switch is equal to 2, then return 1 kilogram of ABS, because we're setting the condition of 2 to be equal to ABS. And if not, then return 0. I'll close out my expression box, and you can see now that these are both functions that are driven by the material switch parameter. So let's see how this is going to work. Right now, if we open up our parameter window, we'll see that our material switch parameter is set to 1. We can see in our model that we are drawing 1 kilogram of propylene from our market for propylene card right here. If we change our material switch to 2, then what will happen is these two numbers will switch. Now we're drawing 1 kilogram of ABS from our ABS card, and we are drawing 0 kilograms of propylene. So you can see how the if statements have encoded this logic that allows us to swap between these two data sets when we are running our calculations. So if I turn this back to 1 and then calculate the environmental impacts of this model, we can see that the environmental impacts of this toothbrush are 121 grams of CO2 equivalent. And if we check our hotspot view, we'll see that 44.4% of our environmental impacts are coming from that propylene material. Now, if I switch this material switch to 2 and recalculate our model, now our environmental impact is 198 grams of CO2 equivalent, and you can see that most of that impact is coming from our ABS material. So this is how if statements can be used to encode logic into our model that allows us to select between two different options. And we can plot these options side by side by running a scenario analysis. So let's create two scenarios, one in which our handle material is ABS, and another scenario in which our handle material is propylene. We'll set our parameters in those scenarios to 2 and 1 and click calculate. So here we can see how ABS has a much higher environmental impact than propylene when it comes to our toothbrush. And if we select life cycle stage to see how this histogram breaks apart the environmental impacts by specific life cycle stages, we can see that the production stage of this life cycle assessment is equivalent between these two materials, but the material acquisition and pre-processing stage is much higher for ABS than it is for propylene. So this is why logic statements can be so powerful. They allow us to make these head-to-head comparisons between two different materials, processes, or designs to compare the environmental impacts of our product decisions. If we open up our expression window, you may have noticed that there are a few other interesting functions in our syntax guide. These include round, which will round a value to its nearest integer, ceil, which will always round a value up to the nearest integer, or floor, which will always round a value down to the nearest integer. An optional second argument for these three functions specifies the number of decimal places to round to. You can also use max or min, which will return the maximum or minimum value of all of the inputs that are listed within its parentheses. All of these functions allow more complex logic within your CarbonGraph model. For example, you can nest multiple if statements within each other for more complex logic switches, or, as I'll show you here, you can nest the round function within an if statement so that this expression will always be guaranteed that material switch will be equal to 1 or 2. What this means is that if we accidentally change our material switch parameter to 1.3 or 1.7, for example, our logic statement will round it to 1 before passing it in to our if statement. I'll show you how that works. If we open up our parameter window, previously, any material switch value except for 1 or 2 would return 0 after it goes through the if statements. Now, if we add in a value like 1.3, for example, our if statements will round that value down to 1 and compute the impacts for propylene. And if we enter 1.7 as our material switch, it will round that material switch value up to 2 and compute the environmental impacts for ABS. So whether we're looking at if statements, rounding, or min-max statements, these functions allow you to encode more complex behaviors into your models. You can run scenario analyses on different options, create logic to bound ranges in multiple ways, and more. And remember, if you ever need to brush up on the syntax of these statements, scroll over to hover for built-in functions, and you can see the available operators, built-in functions, and built-in constants that you have access to in CarbonGraph. See you in the next video, and looking forward to seeing what sustainability advantages you can prove with CarbonGraph.